Right, this is Shane, and it's a video for um, this bearing cup. And as you can see in this drafting, the sketch is kind of confusing. So I'm gonna show you how to make this part. Okay, so as usual, you want to build a new file, a modeling file, and make sure it's in inch. Okay, so once you're in there, so I'm gonna create a new sketch. So usually we think that z direction is the direction of height or thickness. So we will create this sketch on uh, the YZ plane. Okay, now in this YZ plane, we can start the sketch. And if you look at this geometry, of course, this is first it's revolve, and you probably can make this maybe extrude, but it seems to me it's quite a lot of work. So revolve, so you only need to draw this half. Okay, about the hole, you can leave it to the last. You can extrude another cylinder, or you can make it your sketch exactly like this cross section here. Alright, so that's the idea. Then let's first start. And if you look at this, it's made out of sheet metal, so it should have uniform thickness across this cross section, which is 1/16, and that's what you want to make sure they have the same thickness. And we will start from a rectangle from this left side to the right side. So if let's say if we choose to revolve without the hole, okay, I'll start from the origin. Then the width will be a half of this 1 inch. It's going to be 0.5, and the height will be 1/16. And since the width moved, so I need to re-enter this. Okay. Now it's there. The shape is fixed. So just a click, then you can have this rectangle. Alright, then we can start making this bump. I don't know how to call this, but anyway, so basically this is two straight line first, then you can make a fillet. And as to this big arc here, I would use edge blend instead of fillets. The reason being is if you add another fillet here, it's probably gonna bring in a lot of under constraint. If you're fine with under constraint sketch, then you can do that, but it's better to have fully constrained. Now for this bump, so we have this kind of triangle here. Now we can add, first we can add some dimensions to define the shape of this triangle, or you can fillet first. I think fillet first is fine. So radius 0.06 and hit enter. Now we can click this corner. Alright, now if you look at this 0.75 diameter, that's actually from the center of this arc, or rather the center of this yeah, that's the center of this arc. I mean this center, not the midpoint. Okay, so I'm gonna add this from here to z-axis. Well, actually it's y-axis. It's the absolute z-axis. You're looking at the top, and the YC is your sketch axis. So that's the same thing here. So that's gonna be 0.75 divided by 2. And now you can tell it's skewed So if you want to, I want to make this have the same angle on both sides, because underneath here you will have a ball for this ball joint, ball bearing. So you want those two sides to be at the same angle. So how do we make that? You can either put two dimensions here for angles, or if you think about it, this is like a triangle, so you can make them, those two lines equal to each other. So we can have a equal length constraint for this to that. Okay, now we can keep adding dimensions, and this 0.15 is from the very top to the bottom. So here you want to pick the arc. So now you're picking up the arc. If you move your cursor like this, and there's an icon beside your cursor that says the center of your arc, so that will pick up the point. Okay, so here let's turn off the snap. Then you can click the arc. Second, you can click x-axis. That will be the distance from the very top to the bottom, which is 0.15 inch. Now next, you just need to trim this off. So we can use quick trim and take this out. Then that's all for the top. And let's see. Yep, that's all for the top. You don't need to fillet this, or we can do that later. Let's finish the bottom. So that's exactly the same as the bottom. So I'm going to make this triangle first. Then you can fillet this 0.06 for this corner. Then probably need to put another dimension for the center point of this arc to the axis, to y-axis. You can make this equals to P3. So next time if you want to change, you only need to change P3. Alright, next, make them equal. You don't have to go there for geometric constraints. You can simply click. Notice you have this quick menu here. So if you click one line, you would have some possibilities, those possible constraints you can apply to this line. And if I click the second line, you see the constraint changed. So between those two lines, we can have those relationships, okay, or they can both be horizontal. So let's make them equal, which is here, equal length. And you have this. What's the difference here is it's pretty obvious here, and because this is sheet metal, you want the thickness to be constant everywhere. So obviously it's too thick here, so we can use another constraint, another dimension between the two center of the arcs, make them the same as P1, which is the thickness of this sheet metal. Okay, so that's done. We can also trim the bottom off. Okay, and as you can see, now it's fully constrained, and we don't need too many dimensions to fully constrain this sketch. So let's try to fillet this 0.2 inch. Click this corner, click that corner. They all look fine, and except I need two constraints. So if you active this infer dimension, you see this section is actually not constrained. Why? Because this line, this straight line, and that line, they were equal before, but now since we made the fillet, they're not anymore. So how do we constrain them now? You can put those two, you can calculate how much this would be. Let's see, maybe put those two on a construction line, put this vertical, or you can put another construction line here, make this construction line equal to this line, and make the construction line and okay, I'll do it just from this line to this, and this is the original line that's got filleted. Okay, so I'm going to turn this to reference, and we need to add some constraints. First, of course, is make them equal, which is here. Then this point is not on this dash line. Okay, if you drag it, it can still go away. So I'm going to Control Z. I'm going to add point on curve, because this line, the end point, is actually on this curve. So you want the left side to be exactly the same as the other side. So, of course, another thought is you can mirror this to the left side. That should do the same thing, but I'll stay with my plan. Okay, that is good, and we can make another line for this bottom here, and this should be a little bit easier to see how this point is not on this curve. So this is the curve, that's the point, and let's make them equal. So pick this line, pick that line, pick equal length, turn this to reference. Now it's fully constrained. Sometimes after this step, it's still not fully constrained. Why? Because this line and this solid line, they're not collinear, meaning this line can actually steer away from this short line. So you might need a collinear constraint here. But since we talk about edge blend, I'll just let's see, I'll just leave the bottom without the fillet. Okay. Then make the top as the fillet. So here we can make this back to the sharp corner, and you can use quick extend. There's a better tool called make corner. Okay, so you can let two lines that's not parallel make a corner. Okay, and we need to put back the equal length constraint. So now it's fully constrained. The top is with two fillets. The bottom doesn't have this one. You can use edge blend, and furthermore, you can even add this straight line here, and see this diameter. That will be a 1/4 inch, so this will be 1/8. Now when you revolve, you can pick this area instead of the whole thing. So since I'm not going to revolve the whole sketch, I have to finish sketch first. Then we go for revolve, and here if you choose you use invert curve as your curve method, curve rule, you're gonna pick the whole thing. So I'm gonna pick this one, region boundary curves. So this actually picks the area. So I'm gonna pick this area. Then for the vector, okay, you can pick one z-axis. It's already there with the direction, which is vector, and the point, which is the sketch origin. So this is faster way to pick and revolve. So let me deselect. Some of you might just pick a Z from here. So after that, that's not enough, because you're just picking a direction that's parallel to Z axis. So you need to define where that direction located. So you need to specify the point, which in this case is the sketch origin. So let's try maybe, as I said in the lab, you can change this point. So this direction is still the same as Z direction, but the point changes, so that's why it's easier to just pick that Z, which is already there. Okay, now, so if you look at this, the top is good. The bottom should be the sketch without this fillet. So if you did it this way, you can use edge blend, okay, and the radius will be 0.2. Hit enter. You want to pick this edge, then blend it. Okay, then just click OK. Now that's the bearing. If you want to take a better look at it, you can go for View in this menu and go for Section. Here's New Section. So let's change the tab to Assembly Navigator. You see there's a section here, right? So if we build a new section, okay, so it's asking us to pick one orientation. You can simply use X, Y, Z, okay, to see which one fits your need. Okay, so to me, I think this one is pretty good. You can see the sketch. You can also see the solid. Once you click OK, in this Assembly Navigator, under Sections, you have this Section 1 here. Okay, if you double click, it will deactivate, and if you click again, it will show you this section view of your model. And also there's a checkbox in front. If you check it, it will show you the edge. Even if you double click to deactivate the section view, you can still see the edge. So you can also clear the checkbox. That will take you back to where you started. Okay, so I guess that's all for this part, and you can save it.